Hello and welcome to tribetopper.com.
In this video on irrational numbers. So friends, in the previous video we had learned about rational numbers, and rational numbers are the ones which can be expressed as the ratio of two integers. Now in this module we are going to learn about irrational numbers, and as the name suggests, irrational numbers are the ones which are just the opposite of rational numbers. So if that means that irrational numbers will be the numbers that cannot be expressed as the ratio of two integers. So we have learned that all integers, terminating decimals and non-terminating repeating decimals are rational numbers. Then which numbers are irrational? And for that, let's check it out. So first of all, I would suggest that we check out for the square root numbers, like the numbers which are not perfect squares, like square root 2, square root 3, square root 5, 6, 7, all these are not perfect squares. I am leaving out square root 4 and 9 here because they are perfect squares. So infinitely you will have many square roots which will not be perfect squares. So they all fall under the category of irrational numbers. So one is that square root numbers which are not perfect squares, and then we have some of the famous constants like pi and e. These values are also irrational because if you look at this pi, its value is 3.1415926 5, 3, 4 and so on. It goes infinitely, and it's a non-terminating and a non-repeating decimal, so this would be an irrational number. And similarly the value of e, which is actually 2.71828182846, and you continue. It's again a non-terminating and a non-repeating decimal, so this will also be an irrational number. And to remind you that there are not just few irrational numbers, in fact there always exists a minimum of one irrational number between any two rational numbers. So you can imagine between all rational numbers there will be many irrational numbers, and the collection of rational numbers and irrational numbers together make up real numbers. And now to further extend this topic, we would actually do some questions which are not as simple as that to tell whether it's a rational or an irrational number. Your most important question is, prove that square root 2 is an irrational number. And since the question demands that to prove that square root 2 is an irrational number, so we start with a hypothesis, like we assume that square root 2 is a rational number. So we say, let us assume that square root 2 is a rational number. We start with the opposite of what we want. Now that means that square root 2 can be expressed in the form p upon q, where of course p and q are integers, and there is no common factor between p and q, because this we assume to be the simplest form of square root 2. So it can be written as p upon q, where there is no common factor between p and q, which cannot be simplified further. And now, so to take it further, we would say squaring both sides, that would give us 2 on the left hand side and p square upon q square. So this gives me that p square is equal to 2q square. And if p square is equal to 2q square, this means that p square is an even integer. P square is an even integer because I get it by multiplying 2 with q square. So even if the square of q is, say, a number 9, it's odd, but when you multiply it with 2, you would get 18. Therefore, p square is definitely an even integer. And if p is an even integer, then that means p square is an even integer, then that means p would also be, so p is also an even integer. And whenever we say some number is an even integer, then it can be expressed as 2 times k. So whatever is the value of k, irrespective of that, on multiplying with 2, you would get an even number. So p can be expressed as 2k. Now since 2q square is equal to p square, which we just got, we would say 2q square is equal to 2k whole square, right? Because we just assumed that p is 2k. This gives me 4k square. So 2q square is equal to 4k square. Therefore, q square is equal to 2k square, right? Now this gives me that q square is also an even integer, which means that q would also turn out to be an even integer. So now we are getting that p and q both are even integers, but we just assumed that if root 2 is expressed as p upon q, we said we took this condition that p and q do not have any factors in common. But now we are getting p and q as even integers, which means they both have 2 as a common factor. Since 2 is coming out to be a common factor, it is contradicting our assumption that there is no common factor. Hence, our assumption is completely wrong. Square root 2 cannot be expressed as p by q because they have a common factor. Hence, square root 2 is an irrational number. I hope you understood that. And now since you know that square root 2 is not a rational number, so I proceed to a question which says, or which asks you that, what about square root 8? Is it a rational or an irrational number? See, square root 8 can be written as 2 times square root 2. Of course, it's not a perfect square, though we are multiplying square root 2 with 2. Now 2 is a rational number, but a rational number on being multiplied with an irrational number would result in an irrational number. So that means that your square root 8 is an irrational number. And similarly, if I ask you, what about square root 3 upon 2? So though 2 is a rational number, but again, dividing an irrational number by a rational number would again give you an irrational number. That means an irrational number on multiplication by a rational or an irrational number would result in an irrational number. I hope the concept of irrational numbers is clear to you. And in our next video, we shall continue with finding a rational or an irrational number between two numbers. So thank you for watching, and if you think you find this video helpful,
please follow us on Instagram, Facebook and Twitter at tribetopper.com.